We're going to talk today about conjoint analysis and how you use conjoint analysis to predict new product success. So I'm Marc Dotson. This is my second year here at Utah State. I'm faculty in DAIS and a mentor in the ASC. And conjoint and discrete choice modeling is my baby. It's what got me into marketing, actually. So my training is in quantitative marketing. So super excited to share it with you and give you a chance. Hopefully, I mean, when Doug talked to me about this, the intent was that some of you might want to use this for some of your cohort projects. So we'll get some hands-on practice here in just a second. So to get things started, if you haven't been to a PyData meetup before, I can tell you a little bit about it. So it is a club here on campus, but it's also a professional chapter of a larger organization. I think there's like 300 something chapters around the world. It's a forum to learn and to retool. Workshops that we put on vary from very beginning to very advanced. And even though it's called PyData, it is polyglot. So we'll do Python, we've done Julia, we'll do R in the future, etc. There's a code of conduct we follow. So like be nice to each other. And you can join, there's a channel on the DASA Teams channel. There's a PyData Northern Utah. That's our chapter. And you can also join on Meetup. The benefit of this is that even though it's a student club, since it's also a professional organization, you can stay part of it even after you've graduated. So we hope that it's one way to stay connected with and to give back to what you've experienced here. Marketing Analytics Club is new. It's for anybody who's interested in the intersection of marketing and data analytics, and what we're talking about today is very much part of that. We do education, engagement, employer opportunities. We meet once a month. There's also a channel on the DASA Teams. So check us out. We're doing some fun stuff. It's new this semester, so this counts as our second meeting for that as well. So let's talk first about conjoint. And to get there, we need to have a little bit of a foundation in terms of what we're trying to do with conjoint. So many of you, if not all of you, have taken a class where you've done some sort of regression. So regression is in a class of models in machine learning called supervised learning. And whenever we use supervised learning, we are using those models to extract some kind of information from the data, hopefully to inform some sort of decision that we're making under uncertainty. That's most business problems. So if you're trying to develop a new product, you definitely are operating in uncertainty. You don't know how the product is going to perform. And you would like to make the best decisions possible in terms of designing that product, how to launch it, etc. So for all of these supervised learning models, there's kind of three things to think about, at least in terms of the information we can extract. We can extract predictions, we can extract interpretations, and we can extract causal effects. So all supervised learning models can predict. That's what they do. Some of them can be interpretable, and fewer still are causal. So if you only care about prediction, then a flexible black box model can work really well. This will be the kind of stuff that you learn in 5610 with charade, neural nets, things like that. An interpretable model is needed when you want to understand why a prediction was made. So this can be important for explaining what sort of things are happening in your model, or if you're actually really trying to understand something about the underlying process that you're modeling to inform a decision. If you want to intervene to cause a change, you just don't want to just like predict an outcome. You actually want to affect the outcome. That's when you need a causal model. So for causal modeling, there's really kind of two very broad sort of ways to approach it. We can run experiments, which is the kind of the gold standard. If you run an experiment, you have control over what's going on and what, in a way that you wouldn't otherwise. The second approach is to use observational data. So you just observe something happening. If you're interested in causal modeling, that's what we introduced a new class this last year. This is data 5620, 6620. And we talk about conjoint and then this broader framework in general. But let's talk about our problem for today. We're trying to predict new product success. And in order to predict new product success, you've got to estimate or give your best guess of what demand is for the product, right? It can be the best product in the world, but if people aren't going to buy it, it's not going to be successful. So how do you estimate product demand? Well, if you have a new product, especially if it's a hypothetical product, it doesn't exist yet, right? So you can't do like a test market. If anybody's like operated in a test market, I did my PhD at Ohio State. Ohio is a really popular test market in terms of a location in the country that's pretty representative of lots of different locations. So like Wendy's has their headquarters there. So they would all do all these crazy test market things. Like you go to a Wendy's and it would be like a new design of like the building. They were like testing like architecture, or different like sandwiches and stuff would show up that they would try out there before they tried it elsewhere. So there's lots of ways to evaluate product demand, but especially if it's a hypothetical, if you don't have a test market, like, well, what do you do then? So we could just ask people their preferences. We could show someone a product and say what they think about it. But stated preferences are very unreliable. In fact, you really should never make a decision based on what people say. What you can make a decision on is what people do. But again, the product doesn't exist. So what can we do? So people are good at making choices. What we'd like to do is have them make some, even if it's hypothetical, let's have them make some choices. And then instead of them stating their preferences, their preferences can be revealed. We can back out based on their decisions what they actually prefer. This is important, not just because stated preferences are unreliable, but consumers often don't even know their preferences. It's like really hard to state something that is latent. It's like a type 2, like subconscious sort of thing. But you know how to make choices. So we're really good at that. We can use choices to help elicit what their preferences are. Even better, if you can estimate your product's demand as a function of its features and price. So let's take a product and like decompose it into these different features. Then I can get preferences for those different features and actually design a product that we can expect to succeed. So it's not enough to just like, I have a really cool idea for a product and like I'm feeling it in my gut and I'm gonna go with it to market. This is gonna be successful. What you'd like to do is to actually evaluate and estimate demand for those different features so you can optimize and introduce a product for which you can expect there to be demand. And that's where Conjoint comes in. So Conjoint analysis is a survey-based experiment for estimating product demand, where the product features and price are evaluated all at once, or jointly, conjointly. That's where the name comes from. So that's enough of a description, unless anyone has any burning questions about that definition. Let's try it out. So go to this. I have a conjoint for you to take. This is a little survey. It'll take you probably like 3 or 4 minutes. Go there, take that survey, and then we'll move forward. We're doing this live, so if anything breaks, I apologize. Looks like most people, exercising is the most common place you use headphones, followed by studying, and some weirdos who wear their headphones when they're sleeping. Awesome, just like my son. Great. Age mostly 21, 22. And then to actually look at this analysis, we need to actually start a model running. So I'm just going to click on this, and it's going to do some stuff for us. Okay, while that's running, let's talk a little bit about what you saw. So this is not a description of like survey research generally. In the class, we actually talk a little bit more about this. But the conjoint wasn't the first thing you saw. There were some questions that came before and then some questions that came after. And there are right ways to do this. You want to have a funnel so it's easy sort of for people to answer questions, to get them into the middle of the survey, which is the conjoint, and then you ask like sensitive demographic questions at the end. But asking questions outside of the conjoint itself is actually really important. So again, conjoint is just the experiment that's embedded within a larger survey. And what you saw were this setup. So we have a number of different questions or tasks. You answered 10 of them, I think, right? An important point to keep in mind. It means that in terms of the structure of the data, we will have repeat observations for each one of you. This is very simple. This is just in text, but you can have conjoint that's constructed using images. There's some really interesting stuff where you actually feed the stuff into like an AI and like prompt the generation of different like products, that ways they might look. Lots of cool stuff you can do. This is as simple as it gets. So on the left here, we have the different features of the product, right? So you're looking at earbuds here. And then inside of the conjoint itself, you have these multiple different alternatives products you can take. There's also a none option for you that's not shown here. But the task is simple, right? It's just making a choice. So again, it's hypothetical. This doesn't have to exist, right? We could evaluate anything. We want to have people make a choice. And because this is an experiment, I have control. The things you saw were designed in the background. It was created by me, automated by the software to create what's called an experimental design that will show certain combinations of these are called levels, of these different features, so that I know what you chose and I know what you didn't choose. So there's actually a ton of information for each of those clicks, conditioned on the experimental design that went in to create this experiment. So let's just break that down a little bit. So products in conjoint analysis are often referred to as just the features or the attributes, and each of the attributes has a number of levels, right? So like brand you may not have seen all of them. You probably did. There was just like 3 levels. Some of these were just binary, like yes or no, is it present? Then we also had different levels of price. All of those go in to the experimental design. One important limitation to consider is that the attributes and levels really define the whole, not just your product, but the competitors as well. So we want to make sure that we specify the attributes and levels in such a way that we can capture the essence of our product and our competitors, which will be important later. So super important to get this set up correctly up front. You really can't fix it later without collecting new data. Respondents in the survey, then, as you did, you went through and you choose from among these different product alternatives, or maybe that none option, and you did this multiple times. What it's going to allow us to do, because we have repeat observations for each of you, what this model is doing, hopefully works in the background, we will get respondent level preferences estimated for each of these attribute levels. So we'll talk some more about that. That's really the discrete choice part of this. We're going to take those preferences and we can do lots of cool things. We can predict how the product will perform. We can predict this. These are called counterfactual predictions. We can simulate a marketplace. So we can say, how will this product that we're considering perform against competitors? All defined within the bounds of the attributes and levels that we've specified. So these market simulators are really important. This is like the main sort of takeaway. You can think about like a dashboard, and we'll see it in a second, that allows you to consider different products, different ways to combine them, how they compete against competitors, whether or not you're cannibalizing from like a product line optimization perspective. So there's lots of things that you can do with this technique. Okay, let's see if this is actually finished running. Okay, cool. All right, we'll come back to that in just a second. Let me see. All right, awesome. All right, this is ready for us when we come back. Let's talk a little bit about how we actually estimate this. So this is very intro level. Just want to give you some context, and then we'll look at the market simulator. So this is what's running it in the background. So discrete choice is just what it sounds like, right? When you make a choice, you could only choose one of these products. You didn't buy multiple products, right? This is the model that goes on in the background. So for any discrete choice, we assume something really simple. And for those of you in my class, you know what this looks like. What is this? And those of you not in my class, I'm sure you've seen something like this. What does this look like? It's a regression, right? Some form of regression. In this case, for a discrete choice model, the outcome is unobserved, but we're going to figure this out based on the choices. And that's the utility. That big U is going to be utility that you have as a respondent for these different products. What this goes into is we're just going to, if you are a utility maximizer, and we are assuming you are, then you just choose the product that gives you the most utility, okay? So in this notation, this H is the respondent. It's usually household, that's where that comes from. And then J is the alternative. So for any given choice tasks, there were at least 3 of those, right? Defining for each of the different alternatives. And then this is composed of that attribute level breakdown. So these X's are the different attribute levels. So for alternative 1, so if J is equal to 1, that's the first attribute level. So I think it was brand first. So it's like, maybe this is Apple, and then this is Bose, et cetera, right? And in our case, these are all like discrete. They're all, you can all be like they're dummy coded, right? 100 coded. So those X's are all of the attribute levels. And then the betas are just like the regression coefficients, right? But here, those betas represent your preferences. What sort of weight are you as an individual attaching to each of those attribute levels? So one important thing to note here is, yes, I have a different beta associated with each of the attribute levels, but what's different than what you might see in a typical regression? So maybe if I look at these betas, what looks different? I have 1 through k of them right here, but what else do I have? I have a different set of betas for every respondent. So typically when you run a regression model, you assume that the betas are the same for all of your observations, which is a really strong assumption. But we're going to be using a type of model here that allows us to estimate a separate set of betas for each of you. So in this model that we just ran, I have your preferences, each one of your preferences, which means I can do some cool things. I can aggregate everybody up into one group, or I could think about differences based on your listening preferences or on your age, and I can start to target very specific markets. How we typically do this, right? To get these betas, if I want separate betas for each individual, you could think of a situation where, what if I just ran a different model for every person? That's hard. For each of you, there were only like 10 observations, so probably not enough data to work with. And you're not all totally different from each other. So neither are you all the same, where I have one set of betas for all of you, and you're not all totally different from each other, where I would have a separate model for each of you. The models we run do this thing called an adaptive pooling procedure, where we can share information. So even though I have very little information for each of you, I can share that information across all of you to be able to get estimates for each of you. The models that allow for this structure go by lots of different names. So I often call them hierarchical models or multi-level models, but you might see them referred to as mixed models or random effects models. There's lots of ways to think about describing them. But for discrete choice, the combination of that utility maximization, which is just a type of regression, combined with the structure that allows us to have these observations that have control for these repeat observations, allows us to do some cool stuff. So let's go ahead and look at our outcomes. So the first thing we can see is just kind of like it's an importance sort of thing. It's a type of parameter estimate. So these are all normalized to be around 0, but I can see at a high level just what sort of things you prefer. So most everybody here prefers Apple relative to Sony and Bose. Bose the least. In terms of the color, you prefer white. I guess that makes a lot of sense if most of you are Apple. I think they only do white ear pods. In terms of ear tips, silicone was preferred over at better to have none than plastic for you guys. That's good to know. This is not surprising. For battery life, more is better. For noise canceling, yes, please. And then charging case, yeah, that's good. GPS tracking, yeah, sure, but you don't care about it as much. And then price, that's interesting. So it's not just this is actually really an interesting thing. So usually in price, we give a really broad range because price is a signal of a whole bunch of information. And here you're clearly associating it with some sort of quality. So 150 is actually preferred to $100. So good to know for designing a product and for pricing a product. So I teach Conjoint in my class, but in marketing, there is a pricing class, B2B pricing class, which is the other place on campus where you would get Conjoint. They use it specifically in their class only for pricing decisions. Okay, that's just the outcome of the model. So these are just like the parameter estimates. But the thing that's really interesting is to think about a simulator. So in the simulator, it's going to use all of the information that we've gathered, all these parameter estimates that we have for each individual respondent, and then I can construct a whole bunch of options. So let's decide together. Let's create our first product. Let's say that this is the product like we're thinking about designing. Let's say that we're Apple. So let's build this together. What color should it be? White, sure. We saw that was most frequently used. There are Apple products that have silicone tips on the end, right? Okay. All right. Let's say like we're just trying to consider like a bare bones, like a none option. Battery life, what should we say? In constructing the conjoint, like again, these things don't need to make sense. But in terms of the market simulator, like we actually want to construct the product we're considering launching. A whole work week. Yeah, that we would not be able to do that here, right? It's not in the attributes and levels. A whole work week. Okay, I got what you're saying. Yeah, sure. That's the trade-off. We can't do silicone tips, but we can have like a ton of hours. It can't be noise canceling though. We will have a charging case. Sure, there'll be GPS tracking. And let's consider pricing this at, I don't know, $200? At $20? Yeah, we can't, right? That was not an option. So we can only define these products in terms of what was included. So if here I see what that market share would look like, I would have 70% of the market share versus a none option. But any product doesn't exist in a vacuum. So now I can think about alternatives. So let's construct another product. What will be a main competitor? Let's say a Sony one. How should we construct it? The budget competitor, would that be Sony, you think? Probably. So maybe they're budget competitor, but they're also going to try and lean into that brand identification with white ear pods. So budget, so no ear tips, much smaller battery life. Like, what is typical? I don't even, 20 hours? Let's do that. It is noise canceling though. We do have that technology. Okay. No charging case, maybe, no GPS tracking, but really cheap, right? Okay, let's see how that plays out. Okay, so this is our product, and this is our competitors. So this calculation is all just conditioned on the parameter estimates, right? All these separate beta coefficients for each of you. So condition on this and something we haven't talked about, but anytime you do survey research, right? You know, like garbage in, garbage out, just like anything. But you got to make sure that you have a representative sample of your target market. So assuming that this is a good representation of our target market, and these were the only two products, then you saw how much market share went to this budget option. Okay. And we can keep doing that. We can play all sort of what if situations. That's the whole idea of it being counterfactual predictions. These are not things that have to exist, but we can play this game because I've gotten your preferences and I can play this game. What would happen if we did this and our competitor did this? Or we could think about what if we had a product line that included a budget option that was the direct competitor? How much share would we take away from them versus just taking away from ourselves, cannibalizing from ourselves? And is that worth it? Another thing that we can do here is actually include. Oh, that's not what I want. But we can look at this not just overall, but we can break this down by those additional questions. I told you I was doing this live. I can't remember where to. Okay, no segmenting. Okay, here we go. Let's do this by headphone use. So what if we were just trying to create a market where it's just for studying? We saw that was the most common situation. And in that situation, that looks about the same, right? We see the same sort of breakdown. Let's look at the differences by age. How is that different? Okay, so we see that for our product, it's most preferred in this age group, this 25 to 30 age group. But for the competitor, that's mostly preferred by the 30 plus. I think that's just Doug, actually.
Only one with 30?
Yeah, I took it earlier, but I answered randomly, so it's not great data. But that's the idea. So once you have the data, you can do all sorts of cool things with it. You can break it down by different segments, etc. Okay. A nice thing is if you want to do this on your own, you are welcome to scan this, and this will add you to a list under a license I have from teaching this in class. The tool that we're using that has this all set up is called Discover. It's a product from Sawtooth Software. They're very big in the conjoint space. There is like a Qualtrics module that will handle conjoint specifically, but that's not covered in the university license. So if you'd like to do this for actually anything you want to do, if you wanted to run your own survey, the only limitation here is that they will only let you collect up to 100 respondents. So, which is fine. But you'd have to collect your own data. Like that's your thing, but this will allow you to play with creating a survey if you want to. So there's lots of different, oh, sorry, yeah, I'll let you do that. Any questions about how this works? Please. What would we lose? Yeah. So like a central tenet in the whole field of marketing is that if you took that information versus the information, if you took stated preferences versus revealed preferences and that compared that to like observational data, the stated preferences are not consistent with what they actually choose. So the benefit of having it in a choice situation is we are eliciting these preferences in a way that is very natural to people. I'm going to make a choice. I know how to make choices. In my mind, whether I'm conscious about it or not, I'm taking these trade-offs, right? I'm evaluating this. Maybe I'm focusing on certain things. Maybe I have like a halo effect for a certain brand, or I'm especially price sensitive, whatever that happens to be. If we just ask the preferences, they're just not as high quality. They're very unstable and they're not consistent with what they would actually do. Again, for conjoint, like it's not a perfect match either, because this is just a hypothetical choice. There's not actually money on the line. So there's ways that we've tried to improve this in practice, like a way that I incentivize you to take the survey maybe is aligned with the thing I'm asking you about. So you complete the survey and I'll give you earpods at the end, right? That's a way to do that. But it's never perfect. It's always going to be, but this is a better approximation, a better estimate of what people will actually do in practice. Does that answer your question? Okay. Yep. Sure.
And a follow-up analysis, but then it makes me feel like potentially we're reaching the limit of parameters that can be estimated by the data. So
it is typical. The model that we just ran is actually a Bayesian model. So there is not a limit in terms of how much data we have. What we do, generally these types of models, these multi-level models, one way to think of them is that they're just like a huge interaction machine. In these, I don't often specify a separate interaction because the whole thing is an interaction, right? So yeah, that sort of structure is captured within instead of having to specify a separate interaction, it's captured in the structure of the model itself. That's a good question, though. I'm happy to talk more about it later. Other questions? Everybody got this? Okay. So to wrap up, so Conjoint is really commonly used in marketing. My exposure to it was after my master's, getting a job at a marketing research firm, and this was like 90% of what we did was develop custom Conjoint for clients, run the analysis, create dashboards. But there's lots of different potential applications. One of them is trying to figure out how to optimize the reach and extent of public transportation options. This is actually where Conjoint comes from. So there's, it's not here today, but there's a small group of faculty in transportation and engineering that also use this technique. So it's kind of been fun to connect with them and see what's still true in the original discipline. I've done some other work where we can use this to think about donations to international NGOs. We also looked at what are the demographic characteristics that drive charitable donations. Again, because we are getting separate estimates for each respondent in like technical language, this is heterogeneity. There's heterogeneity in preferences, right? There's differences. And so we can capture that using these same model structures. I've also seen it used in interesting healthcare applications where like you yourself don't necessarily know your preferences. So if you have like a really, if you take a conjoint, it can help you to like self-evaluate what matters to you. So I've seen it specifically for like cancer patients, thinking about the trade-offs between different cancer treatments to help them to make some decisions. So there's lots of interesting things you can do with these applications, and it's not just a marketing thing. These are links to both the PyData, Northern Utah. These are the channels on DESA teams, but PyData this semester is all here at Innovation Lab, so show up, you'll keep seeing these. But if you want to join anything with Marketing Analytics Club, you can go there or just look for the channel on Teams. But thanks for letting us do that. I hope that's helpful for your family.
All right, that's it for today. Hang out, work, go on your project. If you have any questions for me or for Mark, we'll all be around.